Okay, this is Dr. Bishop again. I'm going to talk a little bit about the experiment, and then there's another set of PowerPoints that I'm not going to lecture on, but you can look over them, which details correlational methods and contrasts them somewhat with the experiment. You can look over those on your own. Okay, so I'm going to do this by giving a concrete example and then raising questions to help illustrate some of the key concepts. So here's the thought experiment. Imagine that when you walk in the door this week, or just imagine that you walk into a classroom and I ask the first 15 students to arrive to sit on the right side of the room, and then the last 15 students to sit on the left side of the room. I give each of the left side students a bag of marijuana, a pipe, and a lighter, and I tell them to smoke up. I tell the right side students to wait quietly. Then I give all of the students a math test. After that, I compare the average score of the students who smoked the marijuana to the mean score of the students who did not smoke marijuana. So, first question. What is the independent variable in this study? I'll let you think about that for a second. The marijuana, the group that smoked the marijuana, the group that didn't smoke the marijuana, or the math test? The answer is the group that smoked the marijuana. So, the independent variable, the group that smoked the marijuana, is the variable that is manipulated by the researcher. I gave them all of that stuff so they can told them to do it. So I caused them to do it. So that's a manipulation. Researcher controls who is and is not exposed to the independent variable that is the marijuana. Second question, what's the dependent variable in the study? Well, as you look at this, it turns out that you want to check to see what the effect of smoking the marijuana is, and so you measure that with the math test score. So D is the correct answer. The dependent variable is the variable measured by the researcher. The researcher expects that the scores on the dependent variable will depend upon or be affected by the independent variable. Another question, which group is the experimental group? The experimental group in this case is the group that smoked the marijuana. The experimental group is the group that receives the independent variable, the treatment group. Which group is the control group? The group, it turns out, that did not smoke the marijuana. And the control group is the group that does not receive the independent variable. It's very important that the control group be as similar to the experimental group as possible, with the exception of exposure to the independent variable. So, imagine that the results indicated that the group that smoked the marijuana scored lower than the group that did not. Can I be confident that it was the marijuana that caused this group to be different? It turns out that the answer to that is no. What are some other factors besides whether or not one has smoked marijuana that might affect one's performance on a math test? We call these sometimes extraneous variables. It would be any variable other than independent variable, like smoking the marijuana that might affect the dependent variable, the math scores. So what are some other factors besides whether or not one has smoked marijuana immediately prior to taking a math exam that might influence one's score on the math exam? math education thus far, intelligence, how much sleep the subject got the night before, test anxiety, or all of the above. The answer is all of the above. Is it possible that one or more of these factors, might have covaried, that is, varied systematically with the way I assign subjects to the groups? And the answer to that is yes. An extraneous, this is real important, a co-founding variable is any extraneous variable that co-varies with the independent variable. For example, late arrival co-varied with marijuana smoking. It could be that the students who arrived late were more likely tired, stressed, distracted, any of which might have caused them to do worse on the math exam. So that you can say fatigue, stress, distraction may have be confounded with smoking marijuana. Confounding actually means to mix together in such a way that you can't untangle them. So if some person is extra tired, stressed, therefore, comes in late, distracted, and so forth, that may be the thing that actually affected the math score. And you can't untangle the smoking and marijuana from those factors. So you say you have a confound, or confounding variables. So you need a better way of assigning subjects to the group, and would it be a good idea to let subjects volunteer for which group they wanted to participate in? And the answer to this is no. That would be self-selection or volunteer bias. And maybe students who volunteer to smoke marijuana are also the partiers, the slackers. It might cause them to do worse on the math test. Again, you'd have confounding. Personality variables, conscientiousness, lifestyle variables, the previous experience with marijuana might also confound with the independent variable. So, what would have been a better way to assign subjects to the different groups? Flip a coin, heads go in the marijuana group, tails go in the control group. Or, based on gender, women go in marijuana group, tails go in control group. Well, that's pretty obvious. A is the answer. So you have random assignment to the two groups, and by chance that any single subject will end up in one group or the other, which evens out the effects of the extraneous variables. Again, they call this, random assignment of subjects to conditions. And each subject has as much chance of being in one group, experimental group, as control group. And again, it suggests that the extraneous variables are evenly distributed between groups. Extraneous variables can still affect a particular individual score, like if they're stressed or tired, but you'll have equal numbers of those in both groups, and so that will not cause group differences. Might the fact that some students obviously knew they were smoking marijuana influence the results? The answer is yes, because there's expectations associated with this. So when participants experience some effect just because they expect to experience it, it's called a placebo effect, and that does influence the way people behave. If I'm scoring the math test and I know who smoked the marijuana and who did not, might that influence the way I grade the test? Well, it certainly might, because I might be rooting for the result that I want, and I might fudge it in some way. So the experimenter effect is an effect on subjects due to the presence or actions of an experimenter, and therefore, to control for this, often research does what they refer to as a double-blind study, where neither the experimenter nor the participants know who received the independent variable and who did not. Does this study actually tell us much about the relationship between substance use and academic performance in the real world? The answer to that is no. And the reason, well, they really haven't reported the differences, but if you have a really tightly controlled experiment, even if you find differences, you get what they call high internal validity, which means that you have a level of confidence that the differences observed between experimental and control groups with respect to the dependent variable, like the mass scores, really are due to the smoking the pot, the marijuana, the independent variable. So they talk about this as the extent to which experimental effect is due to the independent variable. If that's true, you say that you have high internal validity for the experiment. However, you typically, when you have high internal validity, because the controls are so tight, it might not generalize to the real world where things are not nearly as tightly controlled, and there's all sort of extraneous variables that might, other variables that might make it less generalizable. So this has to do with the control, the tight control of the experiment, and external validity has to do with whether the results of a study of an experiment will generalize beyond the study. Studies with good external validity tend to be low in internal validity. So, the experiment provides information about causal relationships. Causal relationships. The key features, whenever you hear the term random assignment, you probably almost certainly have an experiment. And it involves manipulation, direct control of the independent variable by the experimenter. Examples that you see in actual real research, treatment outcome studies, you have an experiment to ask the question, does a particular treatment work? You know, giving lithium to people with bipolar disorder. So valid treatment outcome studies, you have to be really clear on the definition of the sample being studied. Everybody that falls under a particular diagnosis, you have to describe the treatment being offered, exactly what it is. You have to have a control or comparison condition, people that did not get this, the independent variable. You do have to have random assignment of clients to the treatment or comparison condition. So in this example I just made up, you might have a group of bipolar patients, and some of them get randomly assigned to get lithium and some to a placebo control pill with nothing in it. You need to have reliable and valid outcome measures, and you need to use a double-blind procedure. So they have another feature where you can generalize across multiple studies and sort of average them out to check to see over a number of different kinds of samples and various experimental conditions, whether when you add them all up, do they have an effect? And so you get a more generalizable outcome. They call this a meta-analysis. So the question when you do this on treatment effects of psychotherapy, they do find that psychotherapy is effective, and it looks something like this. If you have the psychotherapy groups, and placebo, and no treatment, and you have the percent who improved, psychotherapy does over a wide range of types of therapy and samples and so forth, it does seem to work more so than you'd expect by placebo. On the other hand, just a placebo will produce some degree of improvement. So that's useful to know. And if you get no treatment, you know, some people get better anyway, but not nearly as many. Another concept is statistical and clinical significance. Statistical significance essentially means that the probability that the results you observe between your experimental and control group was due to something other than chance. And so if you find differences and you essentially use statistical models to indicate the probability that the observed differences would have occurred by chance alone, and if you find that it occurs that less than 5 in 100 times you'd expect an observed difference to have occurred by chance, you say it's statistically significant. If you have very large numbers of participants, you can get clinical or statistical significance with fewer subjects. However, the real difference may be only a little bit, and so you talk about clinical significance as another concept, and basically is it associated meaningfully with, say, improvement or whatever it is that you're testing for in a kind of real life situation. Is it a really meaningful or worthwhile difference? And so you can have statistical significance but not clinical significance. Researchers that conduct an experiment to evaluate the effectiveness of a new weight loss drug were randomly assigned to either the experimental or control or experimental group or a placebo control group. Results indicated the experimental group lost more weight than the control group. Women in the experimental group lost an average of 10.5 pounds. Women in the control group lost an average of 10 pounds. The inferential statistics indicated there was a 3% probability the difference was due to chance. Is the difference between the experimental and control group statistically significant? The answer is yes. Less than 5 chances in 100, and the result was 3 chances in 100. So statistically, there is a difference there. Is there a difference between the experimental and control group? Clinically significant? Not really. A half a pound, that doesn't make a whole lot of difference. Okay, we're going to stop there, and that's the end.